Our goal is to try to understand how spiral galaxies and elliptical galaxies are related to one another. Here you're watching a simulation of a galaxy going through the process of formation, where the cloud of gas and dust is collapsing down under mutual gravity. There's dark matter spewing around inside here too. And what this illustrates is that what's believed to happen in most cases when galaxies form is that they form a sort of disc-shaped spiral galaxy, kind of like you're starting to see emerge here. But there's also this merger that happens, right, where a lot of these sort of proto-galaxies kind of combine and merge together. And in some instances, what that yields are these kind of crazy spiral arms that you see. So it's believed that most galaxies form this way, into a sort of spiral galaxy. Now what happens, though, is not only do collisions take place while the galaxy is forming, but even long after the galaxy's been around. So like our Milky Way galaxy, for example, is actually gravitationally attracted to the closest other galaxy to us, the Andromeda galaxy. And we're so gravitationally attracted that even though most galaxies are moving away from one another, our two galaxies are actually on a collision course. And this is an amazing simulation, again a realistic simulation, of what would happen when the Milky Way galaxy collides with the nearby Andromeda galaxy. Now, even though what we're seeing here are hundreds of billions of stars that are sort of colliding with each other, what's crazy is they're actually passing right through each other. There's so much empty space, right? The stars don't actually hit each other. But of course, the entire structure of the galaxy is disrupted over this process. And this illustrates how we believe elliptical galaxies form. And there's been a lot of ideas over time of how they're related to one another, but the evidence suggests that elliptical galaxies are much older than spiral galaxies, and that really the way ellipticals come to be is through a series of really large collisions like this, which disrupt the structure of the disk and leave behind sort of this glowing ball of light, which is these elliptical galaxies, right? Where still have hundreds and hundreds of billions of stars, but they don't have that kind of dusty disk structure to them. It's really cool to see these simulations, but what's really cool as well is to see actual pictures of galaxy collisions in process. And this is one of the coolest examples. This is a Hubble Space Telescope picture. These are called the antennae galaxy, all right? And this is actually the collision that's happening right now of two spiral galaxies, right? And you can see this stream of material that's been ripped off of one galaxy, another stream ripped off another. New stars are forming in this crazy process. And so what we just saw in super fast forward in that simulation is actually happening out in the sky. And these galaxies are moving, but they're so huge that even if you went and looked at this 100 years later, it would look almost exactly the same as it does right now. I'm not so certain we'd see any difference whatsoever. Right, so these galaxy collisions are taking place, but we can also see the results of that by when we see these elliptical galaxies out in space. So there's a sense of how ellipticals and spirals are likely related to one another.